Hey, welcome back everybody. This is part 2 of inverse functions. And in this video, we're going to start finding some inverse functions. And I hope you'll find this video helpful. So let's go ahead and get started here. All right, so here's the steps. And this is important that you understand how to write this down, okay? Finding the inverse of a one-to-one function, it has to be one-to-one first, okay? We're going to write y equals f of x. So in other words, that says I'm going to take the f of x notation off and replace it with y. Then we're going to solve the equation for x in terms of y, and finally we'll interchange the variables. This will result in us undoing these operations, and I'll talk about it as we go. And I'll fill these in later. I'm going to start with this one right here. Our very first function is a linear function. We know that that's one-to-one. So let's go to work, and I'll pull up the notepad and we'll go step by step. We're going to use the 1, 2, 3 steps. And first step says interchange that f of x notation, or just get rid of it. So the very first thing I do, one, is replace this with y. Okay, that's the easy part. Now, if you think about what this thing's saying here, what does this function actually do? This thing says, hey, multiply by 3, whatever you put in there, and then subtract 2. Well, if you undo that, you'd have to say add 2, divide by 3. But with that being said, watch how this process will come out that way for you anyway, okay? Step 2 says solve for x. All right, so what we're going to do is solve for the variable right here, x. So to do that, I would have to add 2 to both sides. All right, that gets me one step closer. And next step, we would have to divide by 3. Step 3 says interchange x and y. I'm going to switch the order of this equation. Well, no, I won't. I won't do that yet. That might look confusing. So I'm going to put it like this. I'm interchanging x and y. This is your inverse function. Okay, we would put this as f inverse of x, oops, is x plus 2 over 3. All right, that's how the steps go to finding an inverse function. All right, so I'd like to, maybe it would be smart for us to test this in some way to see if it works. And I don't want to do the formal proof thing with it just to test it. If you're in multiple choice world or something like that, a quick test could get you out of a bind. Let's just test. Let's put something into f, and it's going to go to the range, and we'll find out if f inverse sends it back. Okay. Let's take. I don't want to pick something too big here because I don't want to make it harder than we have to. I guess we could just pick, say, 2. Let's try 2. See what happens. So if I put 2 into f, that gives me 6 minus 2. That gives me a 4. Right? Everybody agree with that? So f sent 2 to 4. We'll see if f inverse sends it back. 4 plus 2 is 6. Right? We're putting 4 into f inverse. So f inverse of 4 better give me 2. All right? 4 plus 2 is 6 over 3. It does send it back. So we would say that's a check mark on that one. Okay? That's how you find an inverse. Just follow the steps. Step 1, take off the f of x notation. Step 2, solve for x. Step 3, interchange x and y. Then finally, just replace this y with f inverse and test if you're in a pinch and you don't want to get something wrong, test it. Okay? I think in this video we have time for one more. I have several examples because obviously they're not all going to be so simple. What will happen to us is the step 2 process of solving can get tricky, and we could have issues with something needing some kind of domain restrictions or something like that. So, and I want to show you a graph in one of them. So let's get right back to work with this one here. All right, it says find the inverse of the function f of x equals x squared plus 1. X is greater than or equal to 0. Okay, This is a quadratic function that is not one-to-one, but its domain has been explicitly listed and restricted. So it is one-to-one. And I wanted to show you this in a graph. So I'm going to put that in here. F of x equals x squared plus 1. Clearly not one-to-one. Put the domain restriction in. X has got to be greater than or equal to 0. Let me get down here. I can't see it. I'm just going to put it like that, although that's not completely right. That'll serve its purpose. I can't get to my key down here because the video thing's in the way. So just for right this minute, that'll be good enough. So there's that function. You can see now that it is one-to-one. In other words, that little line's supposed to be under it, and I can't get to the key right this second. All right, so there's what that function looks like. That's important to see for this video, okay? Now let's get back to work on this thing, and we'll go through the steps. And this time we have f of x, I will leave plenty of room here, is x squared plus 1, and the domain's been restricted right there. All right? And we're going to go step 1, get rid of that f of x notation. All right, so that's done. Step 2 says solve for x. All right? Now, I know the first step here is to subtract 1 from both sides. That one's not too hard to get. Step 2, now if I'm solving for something square, remember we take square roots. So we're going to take the square root of both sides of this thing. I'm going to reverse sides. I'm going to put x squared on this side and y plus 1 over there. So you're going to get x is equal to, technically, plus or minus the square root of y minus 1, right? Do we want the negative version? No, we don't. We don't want the negative version. And I'll explain that in a little bit here. So we get x is equal to the square root of y minus 1. Now, step 3 says interchange x and y. So y equals the square root of x minus 1, and that is our inverse function. All right. Now, we can test this to see if it works. I'm going to go ahead and tell you I know that it's right, and I don't want to test it because I don't want this video to go too long. But I wanted to go back and talk about this plus or minus issue for those of you that maybe that would concern. And I guess what we would say here is, okay, remember the range of this function is the domain of this function. His range is from 1 to infinity. Positive infinity. And that's the domain of this function. So this negative version down here, if that was the negative version we kept, would have a range of everything negative, and that would be impossible, right? That's the reasoning behind it. Another reason behind it, and this is what I wanted to show you, and that's why I wanted to pull up Desmos, is you can graph the inverse function that you find. It's another kind of a test you can do. I'm not going to put the notation in with the inverse because I don't even know if Desmos will do that. Y'all can figure that one out. And I want to put it in my square root, and I can't get to it. Oh, great. Oh, can I move this out of the way? Okay, I corrected my screen where I could get to my tools down here, and because I needed that square root, there's no way out of it this time. I can't. And while I'm at it, I'm going to go up here and fix this, because I just don't like not having things the way they're supposed to be. And we're supposed to have x minus 1 in here. All right, so notice here, there's another property of inverse functions. They're symmetric to the line y equals x. And you can see that symmetry here. In other words, the symmetry to the line y equals x means that this is actually reflected over this line, right? So this is a reflection over the line y equals x, and they always are. And there's a test we can run that shows that. I didn't want to get into all that this way, but sometimes a graph will help you see that. And you'll see that if you use the negative version of this, that's not symmetric, right? So we know that that's another reason just to look at it that way too. That's not it. And that shows you another reason this domain has to be restricted, right? So, and don't forget to restrict domains in Desmos. Use that squiggly bracket thing and just type them in like they look. All right, so we found this inverse function. That's the end of part 2. There is a part 3 because there's another function we have to tackle that has an issue you're running into in Delta Math. So thanks for watching.